All right, we're ready to begin page 3, the last page of Module 3, Lesson 1, some additional examples. So what we're going to be doing as we go through this page is deciding what kind of reasoning would be better. Think back to your tree problem. When we used additive reasoning and asked which tree grew more, we said, oh, they grew the same. So that doesn't really tell anyone anything. But when we use multiplicative reasoning, one tree was 2.5 times larger. The second tree was only 2 times larger. So based on multiplicative, it made more sense to say, oh, tree A grew more because it's 2.5 times its original size. So as we go through these examples, keep that in mind, the two types of reasoning. Is this a problem where I add or subtract, or is this a problem where it would be better to divide and find out how many times larger something is? So this first one with ages is a good example for you to think, is this an addition problem or is this multiplication? So Lisa's 2 and James is 6. How old will James be when Lisa's 6? So this is what your mind should be saying. Do I add to Lisa's age to get James? Or do I multiply 2 times 3? James is 3 times older. So the question I ask myself, if I say, oh, this is a multiplication problem, James is 3 times older, I say, okay, then when Lisa's 3, is James going to be 9? Because 3 times 3 is 9. So in 1 year, Lisa will be 3. Will James be 9? No. So this is not a multiplication problem. This is an addition problem. Because when Lisa's 3, James will be 7, which means 2 plus 4, 6, 3 plus 4, 7. So this is an additive reasoning problem. We can't use multiplication because true, James is 3 times older than Lisa right at this moment. But when Lisa turns 3, James will be 7. He won't be 3 times older than her any longer. So just at this one moment in time, this 1 year, will he actually be 3 times older than her? So Lisa 2 plus 4 equals 6. So Lisa plus 4 gives me James. So I kind of like to turn it into an algebra problem. Lisa's 2. If you add 4 to her age, you get James. So we'll call Lisa L. If you add 4 to her, we get James. And again, we can't use multiplication because true, James is 3 times older than her now. But next year, when she's 3 and he's 7, he won't be 3 times older. That's why we can't use multiplicative. So the reason I like to do this is because then they can either give me J or L. I can plug it in and find the other one. So how old will James be when Lisa's 6? So in place of L, just put 6. 6 plus 4 equal James. So does everybody agree James will be 10 years old? When Lisa is 6. So James will always be 4 years older than Lisa. He won't always be 3 times older than Lisa, but he'll always be 4 years older than Lisa. And this is additive reasoning, because notice it does say, is this additive, multiplicative, or both? It's definitely not multiplicative because a multiplicative only holds for that first year, 2 times 3. So now we've answered both the questions. Excuse me. James will be 10 when Lisa's 6, and we used additive reasoning. Okay, let's switch gears now then. Let's look at number 9. So number 9 wants to know which is a more significant change. A group that grew from 4 to 12 or a group that grew from 50 to 75. So let's talk about it additively first. So additively, remember how we learned you always subtract? So we'll call this group A, we'll call this group B. So we're going to subtract. So group A is 12 minus 4, which is 8 more people. So 8 more people joined that group. 4 plus 8 is 12. For group B, 75 minus 50 is 25. So that group grew by 25 people. So if we were using additive reasoning, we would say group B grew more. Now let's look at it using multiplicative reasoning. And I think in this case, and you'll probably agree, once we do multiplicative, it makes more sense to say that that one is more descriptive of the significant change. So let's go over here and use multiplicative. And you might want to write yourself a reminder that multiplicative uses division. And remember, when we do multiplicative, we keep it in the same order. Excuse me. Get a drink. I've been making way too many videos. So group A, instead of subtraction, remember we're going to change that to division. So 12 divided by 4 equals 3. And do you remember what the label is for multiplicative? So this was units, 3 more people. With multiplicative, remember multiplying means times. So 3 times larger. So group A is 3 times larger than it started out. It was 4 people. Now it's 12, so it's 3 times bigger than it was. Now let's see about group B. Instead of 75 minus 50, we'll do 75 divided by 50. And remember, in division, we need to, once we have our fraction, we need to make sure it's simplified. Does everybody agree 25 goes into both of those? Think of quarters. 25 divided by 25. So 25 goes into 75 3 times, and 25 goes into 50 twice. And then remember, we can do 2 into 3. Change that into a mixed number. 2 goes into 3 once. So 1.5 times larger. So using multiplicative reasoning, which I think is more applicable, it's kind of like if someone makes $20,000 a year and someone else makes $100,000 a year. and they both get a $20,000 raise. Which person do you think had the most significant raise? Don't you think that $20,000 person who just doubled their pay is having a more significant effect on their life than the $100,000 person who just had a 20% increase? Yeah, so we have to look at where it started. We can't just look at the actual growth. We have to compare it to what it was. So this one tripled in size. This group is 1.5 times larger. So using multiplicative reasoning, we can see that group A had the more significant change. And many times you'll see this is true. The answers change when we use different reasoning. So additive, group B grew more. If we use multiplicative reasoning, group A grew more because it tripled in size. Okay, let's look at the next exercise. So a student worker earned a raise. Their hourly pay increased from $8 to $12. Sorry, I kind of wrote over that. So let's write it here. So $8 an hour to $12 an hour. And this is kind of how we have it set up on the test. We give you a scenario and then we ask you for the increase using the two comparisons. So additive wants to know the increase. And remember, on additive, we subtract. So we would say 12 minus 8. And remember, on additive, we put the units in. So she's making, or he's making, $4 more per, and it said hour right there, hour. So that student is making $4 more per hour. And that's using additive, which tells us to subtract, which we learned on the front of the page. So now let's look at it multiplicatively. Did he double or she double their income? What kind of increase did they get using multiplicative? So remember, multiplicative tells us to divide. And we don't switch the order. We just put a division sign in or write it as a fraction. So 12 divided by 8. So same order, just put the division sign in. Does everybody recognize here that 4 goes into both of these? So we can divide both the numerator and the denominator by their common factor 4. So 12 divided by 4 is 3. 8 divided by 4 is 2. There it is again. We already did that one up here. So that is 1 1/2 times more. So anytime we use multiplicative reasoning, we use the word times more. So he or she is making 1.5 times more money than they were after their raise, or they got a raise of $4 per hour. So both of these are correct. They're just two different ways to talk about your raise. I made $4 more per hour, or my paychecks are 1.5 times more than they were. Two different ways to look at it, and this is what we do on the test is we give you a problem and we ask you to talk about it using both types of reasoning. So this would be a really good one to highlight as a test question. I think it's right on the front page of your test, matter of fact. Okay, last problem, and generally when we're in class, this is your homework problem, but we're all home, aren't we? So we'll do this together. So Sue and Julie were running around a track, and here's the key. They were going equally fast. So however far ahead someone is right now, they're going to stay